So this is the first question on this. So on the graph of the function g of x equals e to the x element r from 0 to 1. I'm say diagram plot this graph here, right? So it's simple as using your table function, okay? So your table function is just go to the calculator, put in f of x equals e to the minus x, go from a domain of 0 and ends at 1, so starts at 0, ends at 1, and do a step. Now you see that it goes up in 0.2s, but we can go up in either 0.1 or 0.2, so use a step of 0.2. And when you do this, what you should get is the following. Okay, you should get we'll just make a quick table here, and then we do our x and our f of x value. Now this is once again we use your table function, so we go 0, 0.2, 0.4, 0.6, 0.8, and 1.0. Put that into the calculator, and what you should get is 1, 1.22, 1.49, 1.82, 2.23, and 2.72. Now, when you do this, what you're going to do next is you're going to draw it on the graph. So you have we go 0, 1 is here, and then we go 0.2 and 1. What's it? 0.2 and 1.22. No, actually, as it turns out, stupid me, that's actually for e to the x. Okay, that's actually not for the that's actually not for e to the power minus x. So we'll just wrong points actually. Go again. Okay, and pen. Go again. All right. So once again, we enter this into the calculator, and the points we should get are 0, 1, 1, 0.2, 0.82, 0.4, 0.67. 0.6, 0.55, and then 0.8, 0.45, and then 1.0, 0.37. Okay? And we're going to end up doing is you're going to end up drawing this on the same graph, okay? So that's 0.8, 0.6, 0.4, and 0.2. So 0.82 being around here, 0.67 just being underneath 0.7, and then 0.6 and 0.55, so just halfway between the two of them, and then 0.8 and 0.45 there, and then finally 1 and 0.37, which will just be underneath there, right? So remember, this is a curve, not a straight line, so you just gotta be careful with this. Roughly there, okay? Now, find the area enclosed by g of x. Find the area enclosed by g of x equals e to the x, and the line x equals 0.75. Give your answer correct at 4 decimal places, okay? What you're going to have to do is you're going to have to draw a line at x equals 0.75. Okay? So x equals 0.75 is halfway between 0.8 and 0.8. Oh, sorry, x equals 0.75, excuse me. So that's 0.7 to 0.8. So you're going to do 0.75 up here. Okay? And what you're looking to do is you're looking to get the area enclosed between the two curves. So what you're looking at is this area here. Once again, we'll just get a pen. You want to get this area here, okay, the red area. However, this red area, okay, is a combination of 2 other areas, and I'll explain that now. So this red area could be a combination of first a blue area, which I'll signify now. Where is my blue area? So this blue area here. Now, how do I get this blue area here? Well, the blue area is underneath the g of x curve. So it's the integral of 0 to 0.75 g of x, and g of x equals e to the x dx. Okay, that'll get me the blue area. Now what I'm going to concentrate on is another area which I'll call the green area, like so. And this green area will be this area here. And the blue area minus the green area will give me the red area we were talking about earlier. Okay? And this green area is underneath the bottom line. So it's going to be take away the integral of 0.75 e to the minus x dx. Okay? So we're going to work a lot on this now. Okay. So what we're going to do is we're going to integrate this, and what we're going to get is the integral of e to the x is simply e to the x, 5.75 and 0. The integral of e to the minus x is simply going to be e to the minus x, so 0.75. So it's e to the minus x comes right in because it never changes. Differentiate the power to get minus 1. Then you're going to divide by minus 1. However, when you divide by minus 1, what we're going to do there is we can just put the minus 1 in front instead, okay? And once again, that's going to be from 0.75 to 0. Now we got a bit of work to do on the calculator. This one here is going to be e to the power of 0.75 minus e to the power of 0, which is e to the power of 0.75 minus 1. The next part up here will be minus. Now we're just going to keep an eye on this part here. So it's going to be minus 1 e to the power of minus 0.75, and then it's going to be minus e to the power of 0. Once again, e to the power of minus 0, but e to the power of minus 0 is still 1. Okay, so we're just going to put minus 1 here. Throw all of this into your calculator, and what your answer should get you is you should have an answer of 0.5894. Okay, and that's the first question done. Now, we're on to the next question here. So again, 610 page, okay, and make sure that everything fits in. And we'll just move this down here. So, the height of a water in a pot was measured over a period of time. The average height was found to be 1.6 meters. The height is measured in h to the power t, was modeled using the function ht equals 1.6 plus 1.5 cos pi over 6t, where t represents the number of hours since the last recorded high tides, and pi over t is expressed in radians. Find the period and height of h to t. Alright, so